Hello my dear friends, warm welcome in the 10th standard. Before exploring today's topic, let's recap what we have learned in 9th standard about linear equations in two variables. Recap. An equation which contains two variables and the degree of each term containing a variable is 1 is called a linear equation in two variables. The graph of such equations is a straight line. 3x plus 5y is equal to 15 is a linear equation in two variables as it has two variables x and y and the degree of each of the terms comprising these variables is 1. The graph of this equation is a straight line. Similarly, square root of 3x minus square root of 2y is equal to 0. Minus 5x plus 7 upon 4y is equal to 22 upon 8 are also linear equations in two variables. The graph of these two equations is also a straight line. However, x square minus y is equal to 0 is not a linear equation in two variables as the degree of the term comprising the variable x is 2 here. The graph of this equation is not a straight line. It is as shown below. The general form of linear equation in two variables is ax plus by plus c is equal to 0, where a, b, c are real numbers and a and b are non-zero real numbers. Recap: simultaneous equations. I hope you have best understood the concept of linear equations, right? Okay, you have already studied solving simultaneous linear equations in two variables using elimination methods. Let's revise this. When we think about two linear equations in two variables at the same time, they are called simultaneous equations. Let's see few examples as a revision. 3x minus 5y is equal to 19 and 5x plus y is equal to 30. In these simultaneous equations, there are two variables x and y. We need to find out values of x and y such that it satisfies both the equations. That is, we need to solve these two equations simultaneously. But how to solve these? Well, this can be done by eliminating one of the variables out of the two using given equations. This will help us get an equation in one variable which can be solved easily to find the value of one of the variables. Now, by placing the value of this variable in any one of the equations can give us the value of another variable as well. Elimination of one of the variables can be done in two ways: making the coefficient of one of the variables same or express one of the variables in the form of another variable. Let's explore both of these methods in detail. First, making the coefficient of one of the variables same. Now for this, you need to multiply or divide one or both the equations with appropriate non-zero real numbers such that in the new set of equations, coefficients of one of the variables in both the equations becomes same. This is required only when coefficients of both the variables are different in two equations. Or else, that is, if coefficients are the same already for one of the variables, you can follow subsequent steps. Add or subtract the old and new equations as appropriate so that the variables with the same coefficient gets eliminated and we get an equation in one variable only. We can easily solve this linear equation in one variable to find its value. Once the value of one of the variables is known, it can be placed in one of these simultaneous equations to find the value of another variable. Let's understand this with the help of an example. Now the given equations are 3x minus 5y is equal to 19, equation 1. Coefficient of x is 3 and that of y is minus 5 here. 5x plus y is equal to 13, equation 2. Coefficient of x is 5 and that of y is 1 here. Let's multiply equation 2 by 5. We will get 5 multiplied by 5x plus y is equal to 13. Therefore, 25x plus 5y is equal to 65, equation 3. If we compare the coefficients of y in equation 1 and 3, we can see that it is minus 5 and 5 respectively. If we add these two equations 1 and 3, clearly variable y will be eliminated. 3x minus 5y is equal to 19 plus 25x plus 5y is equal to 65. Therefore, 28x is equal to 84. Therefore, x is equal to 84 divided by 28. Therefore, x is equal to 3. Now, let's place the value of x is equal to 3 in equation 2. 5x plus y is equal to 30. Therefore, 5 multiplied by 3 plus y is equal to 13. Therefore, 15 plus y is equal to 13. Therefore, y is equal to 13 minus 15. Therefore, y is equal to minus 2. Therefore, x is equal to 3 and y is equal to minus 2 are the roots of the simultaneous equations above. Therefore, x, y is 3 minus 2. Points to remember. If we add or subtract the simultaneous equations after making the coefficients of one of the variables gets eliminated. This results in getting a linear equation in one variable. After solving this linear equation in one variable, you can get the value of one of the variables. This can further be placed in one of the equations to find the value of another variable. Such numeral values of both the variables satisfy both the equations and are called roots of the given set of simultaneous linear equations in two variables. Express one of the variables in the form of another variable. Now, for this, we need to rearrange one of the equations to express one of the variables in terms of the another. Put the value in terms of another variable of this variable in another equation. This will give us the equation in one variable which can be solved further to find the numeral value of one of the variables. After placing the numeral value of this variable in one of the equations, you can get the value of another variable. Let's understand this with the help of an example. The given equations are 3x minus 5y is equal to 19, equation 1. 5x plus y is equal to 13, equation 2. Let's rearrange equation 5x plus y is equal to 13 to express variable y in the form of x. That is, 5x plus y is equal to 13. Therefore, y is equal to 13 minus 5x, equation 3. Now, let's place the value of y, that is 13 minus 5x in equation 1. That is 3x minus 5y is equal to 19. With this, we get 3x minus 5y is equal to 19. Therefore, 3x minus 5 into 13 minus 5x is equal to 19. Therefore, 3x minus 65 plus 25x is equal to 19. Therefore, 28x minus 65 is equal to 19. Therefore, 28x is equal to 19 plus 65. Therefore, 28x is equal to 84. Therefore, x is equal to 84 divided by 28. Therefore, x is equal to 3. Now, x is equal to 3. Let's place that in equation 3. That is, y is equal to 13 minus 5x. Therefore, y is equal to 13 minus 5 into 3. Therefore, y is equal to 13 minus 15. Therefore, y is equal to minus 2. Therefore, x is equal to 3 and y is equal to minus 2 are the roots of the given simultaneous equations, that is x, y is 3 minus 2. We can cross-check if xy is 3 minus 2 satisfies both the equations. 3x minus 5y is equal to 19 is the equation 1. 5x plus y is equal to 13, equation 2. Consider equation 1. 3x minus 5y is equal to 19. Now the left hand side is 3x minus 5y. Therefore, 3 multiplied by 3 minus 5 multiplied by minus 2 equal to 9 plus 10 is equal to 19, which is the right hand side. As left hand side is equal to right hand side, xy is 3 minus 2 satisfies the equation 3x minus 5y is equal to 19. Similarly, consider equation 2. 5x plus y is equal to 30. Left hand side is 5x plus y, that is 5 multiplied by 3 plus minus 2 equal to 15 minus 2 equal to 13, which is right hand side. As left hand side is equal to right hand side, xy is 3 minus 2 satisfies the equation 5x plus y equal to 0. Points to remember. From the given set of linear simultaneous equations in two variables, one can express one of the variables in terms of another variable, and after putting this value in another equation, one variable gets eliminated and one can get a linear equation in one variable. After solving the linear equation in one variable, one can find the numeral value of that variable. Using this numeral value of one variable, the numeral value of another variable can be found out easily. Such numeral values of both the variables satisfy both the equations and are called roots of the given set of simultaneous linear equations in two variables. So, try solving the simultaneous equations using the two methods mentioned above. What did we learn? Equations with two variables having degree of each of the terms containing this variable is 1, then such equations are called linear equations in two variables. When we try solving two different linear equations in two variables at the same time, then such equations are known as simultaneous linear equations in two variables. We can solve the simultaneous linear equations in two variables using two methods. First, making the coefficient of one of the variables equal. Thereafter, adding or subtracting the equations to eliminate one of the variables to get the linear equation in one variable. Solving this equation further to get the numeral value of the remaining variable. Then by substituting numeral value of the variable in one of the equations, one can find the value of another variable. Second method, express one of the variables in the form of another variable. Replace this variable in the new form, which is in terms of another variable, to get a linear equation in one variable. This can be solved further to find the numeral value of one of the variables. This numeral value can further be used to find the numeral value of another variable. These numeral values, which are obtained by considering or solving the two linear equations in two variables simultaneously, satisfy both the equations and are called as roots of these two simultaneous equations. Exercise. Solve following simultaneous equations by making the coefficients of one of the variables same. 3m minus 2n is equal to 26 and 7m plus 4n is equal to 0. 9x plus 4y is equal to 1 and 7x plus 2y is equal to 3. Solve following simultaneous equations by expressing one variable in the form of another. 2x minus y is equal to 4, 5x minus 6y is equal to 11. 3x minus y is equal to 5 and 4x minus 3y is equal to 10. Fill suitably the boxes below. Given simultaneous equations are to be solved to find the values of x and y which satisfy both the equations given below. The equations are x plus 3y is equal to 8 and 4x plus 7y is equal to 17. Solution: x plus 3y is equal to 8, equation 1. 4x plus 7y is equal to 17, equation 2. In order to eliminate the variable x, multiply equation 1 with 4. X plus 3y is equal to 8 multiplied by 4. Therefore, box x plus box y is equal to 32, equation 3. Let's subtract equation 3 from equation 2. 4x plus 12y is equal to box minus 4x plus 7y is equal to 17 gives us 5y is equal to box. Therefore, y is equal to box. Now let's put y is equal to box in equation 1. X plus 3y is equal to 8, equation 1. Therefore, x plus 3 multiplied by box is equal to 8. Therefore, x is equal to 8 minus box. Therefore, x is equal to box. Therefore, x, y is box, box are the roots of simultaneous equations x plus 3y is equal to 8 and 4x plus 7y is equal to 17.